In this video, we're going to go over the problems that are in the Unit 6 test review. So the first question says, which graph matches the function f of x equals the square root of x minus 1 plus 2? So the best way to do this problem is to go to Desmos and to enter this equation and look at the graph. So you can see that the graph we get starts off at 1, 2, and it includes the points 2, 3, and 5, 4. So we're going to look for a graph that starts off at 1, 2 and has the points 2, 3, and 5, 4. So let's go through our choices. So you can see answer A starts off at 1, negative 2, so answer A will not work. B does start off at 1, 2, so it looks like a good choice. C starts at 1, negative 2, so that won't work. And then D starts at negative 1, 2, so that one won't work either. Let's make sure that the values of 2, 3, and 5, 4 are included, and they are, so that means that B is the correct answer. So now let's describe how the graph of f of x equals the square root of x could be transformed to the graph of g of x equals the square root of x minus 2. So when we do this, remember, we want to use that transformations chart to figure out what's going on. So we have this minus 2 right here. That's our transformation. It's inside the radical, so we're going to go down this path. So it's going to be a horizontal change. It's being added or subtracted. So we're going to go this direction. And let's see, I see a minus sign in my problem. So that is going to be shifted to the right. So we would say that this is a shift right 2 units. Remember that you can verify this by graphing both functions in Desmos. So we have the parent function in blue and the transform function in red, which you can see is in fact moved to the right 2 units. So now let's write the equation of the transformation formed by vertically stretching the graph of f of x equals the square root of x by a factor of 9, and then horizontally shifting the graph 3 units to the left. So we have 2 transformations going on here, and what we're going to do is we're going to work with them one at a time. So we have a vertical stretch by 9, okay? So vertical means I'm over on the left side of my flow chart. It's being stretched by 9. So let's see what's happening. So stretch when a is greater than 1. So this tells me that a needs to be multiplied, and it's going to be on the outside of my radical. So I'm going to have a 9 multiplying the outside of my radical. So now let's do the next transformation. The next one is that I have a horizontal shift 3 units left. So horizontal means I'm going to be on the right side of my flow chart. 3 units to the left. Okay, so you see it says shift left when h is less than 0, which gives me a plus sign. So it's going to be added or subtracted, and then horizontal is on the inside. So that means that I'm going to take this 9 square root of x, and then I'm going to add 3 on the inside. So this is now my new transformed function. And remember that you can check that these transformations are correct by graphing both equations in Desmos. So you can see that the transformation that I've written in green is in fact stretched by 9 vertically, and it is also shifted 3 units to the left. So in this problem, we're going to work on solving this radical equation. So remember, our strategy when solving radical equations is always start off by isolating the radical. Okay, that's going to be our very, very important first step. So we isolate the radical, and then we raise everything to the opposite power, right? So whatever power undoes the radical, we're going to work on raising everything to that power. Well, you can see in this case, the radical is already isolated, right? The square root is already by itself on one side of the equation. So I'm going to undo that square root by doing the opposite power, which is to square it. If I square one side of my equation, I have to square the other side. So that gives me x plus 2 equals 6 squared, which is 36. So now the final step is just going to be to solve for x, right? So just like any other equation we do, we're just going to work on getting x by itself. Well, x is not by itself because it has that plus 2. So I'm going to subtract 2 from both sides, and that will give me x equals 36 minus 2, which is 34. Remember, when you have radical equations, always the last step is going to be to check our solutions to make sure we don't have an extraneous solution. So when I plug in 34, I get 34 plus 2. And so that tells me that the square root of 36 equals 6, which is in fact true. So my solution is good. So now let's try solving this radical equation. So just to remind you of the steps, always start off by isolating, then we do the power, then we solve, and finally we check. So here my radical is not isolated because it has this extra 6 with it, right? That 6 is a positive 6, so I'm going to undo it by subtracting 6 from both sides. So when I subtract 6 from both sides, that leaves me with the square root of 3x plus 1 equals 10 minus 6, which is 4. Now I need to do my power step, right? So I'm going to undo the square root by squaring both sides of the equation. So that gives me 3x plus 1 equals 4 squared, which is 16. Now I need to solve for x, so I'm going to start off by subtracting 1 from both sides, which gives me 3x equals 15, and then divide both sides by 3, which gives me x equals 5. So I have x equals 5, which I'm going to go back and check by plugging into my original equation. So I have 6 plus the square root of 3 times 5 plus 1 equals 10. So I have 6 plus the square root of 15 plus 1 equals 10. 6 plus the square root of 16 equals 10, which does tell me that 6 plus 4 equals 10, and that is in fact true. So in this problem, it says that the square root equation has two solutions. What is the extraneous solution? So even though it has an extraneous solution, we're going to go ahead and go through the same problem solving steps that we've been using to figure out the solution. So we're going to start off by isolating the square root. Then we're going to raise everything to a power. We're going to solve for the value of x, and then we're going to check our solutions. Remember, in the check our solution step is where we're going to figure out the extraneous solution. So we're going to start off by isolating the radical. Well, the radical is not by itself because it has this minus 2, so we're going to do the opposite, and we're going to add 2 to both sides. So when we add 2 to both sides, we get the square root of 2x plus 7 equals x plus 2. So now we need to raise everything to the opposite power to get rid of that radical. So we're going to square both sides of this equation. So when you square both sides, we get 2x plus 7 equals, and then when we do x plus 2 squared, that is the same thing as x plus 2 times x plus 2. And we're going to use FOIL to be able to figure that out. So we're going to do first times first, which is x squared, then outside x times 2, which is 2x, inside 2 times x, which is 2x, and then last, which is 2 times 2, which is 4. So now we're going to put all these terms together. Remember that the two like terms in the middle are going to combine, giving us 4x. So the total we have is x squared plus 4x plus 4. So we're going to substitute that back into this equation, x squared plus 4x plus 4. So now remember we have a quadratic, and remember that a quadratic needs to be in this form, ax squared plus bx plus c equals 0. So we have to have it set equal to 0 before we can solve it. So to get it equal to 0, I'm going to start off by subtracting 2x from both sides. So when I do that, I get 7 equals x squared. Remember that the 2x will only combine with the 4x because only like terms can combine. So I have x squared plus 2x plus 4. And then I subtract 7 from both sides, which gives me 0 equals x squared plus 2x. And then 4 minus 7 is minus 3. So now I have x squared plus 2x minus 3 equals 0, which I now need to solve for x. So I can solve this by factoring. So I have negative 3, and I need to figure out the two factors of negative 3 that add up to 2. Well, since I have negative 3 as my product, remember I need a positive number and a negative number to multiply to equal a negative number. Since 2 is what I needed to add up to, and 2 is positive, I'm going to make the bigger factor positive. So 3 is a prime number, so the only two factors of 3 are 1 and 3. If I leave the bigger factor positive, I'm going to make the smaller negative. That gives me negative 1 plus 3, which does in fact equal 2. So that means that my factored equation is x minus 1 times x plus 3 equals 0. So now I'm going to set each of these factors equal to 0 and solve for the values of x. So when I do that, I get x minus 1 equals 0. So I add 1 to both sides, which gives me x equals 1. I have x plus 3 equals 0, so if I subtract 3 from both sides, that gives me x equals negative 3. Now I need to go back to the original equation and plug in these values of x. So I have the square root of 2x plus 7 minus 2 equals x. I'm going to first plug in x equals 1, so that gives me the square root of 2 times 1 plus 7 minus 2 equals 1. So that's the square root of 2 plus 7 minus 2 equals 1, which tells me the square root of 9 minus 2 equals 1. So 3 minus 2 equals 1, which is in fact correct. So x equals 1 is the correct solution. Let's try now x equals negative 3. So that gives me the square root of 2 times negative 3 plus 7 minus 2 equals negative 3. So I have the square root of negative 6 plus 7 minus 2 equals negative 3, which tells me that the square root of 1 minus 2 equals negative 3. The square root of 1 is 1, so 1 minus 2 equals negative 3, which tells me that negative 1 equals negative 3, which is not true. So that means x equals negative 3 is the extraneous solution. Notice in problem number 6 that this is not asking us for the actual correct solution, it's asking us for the extraneous solution. Okay, so this answer is going to be x equals negative 3. So now let's describe the solution of this equation. So here we have, once again, another radical equation. So we're going to use our same steps, right? Isolate, raise everything to the power, solve for x, and then check our solutions. So what we're going to do is we can see that this radical is not isolated. We have too many terms with the radical. So we're going to move them over one at a time. So I'm going to start off by adding this x to both sides, right? We're just going to move away anything that's outside the radical. So we have the square root of 2x minus 4 plus 2 equals x. Now I'm going to move away this 2 by subtracting 2 from both sides, which gives me the square root of 2x minus 4 equals x minus 2. Now we have the radical by itself, so we can go ahead and raise everything to the opposite power, so we can square both sides. So we have 2x minus 4 equals, so we have x minus 2 squared. X minus 2 squared is x minus 2 times x minus 2. So we can use FOIL to expand this out. So we have first times first, so x squared. Outside, so x times negative 2, so negative 2x. Inside, negative 2 times x, so negative 2x. And then negative 2 times negative 2, so that's positive 4. We can combine the two terms on the inside, so we have negative 4x. So all of this adds up to x squared minus 4x plus 4. So that's what I have here on the right side, x squared minus 4x plus 4. So once again, I have a quadratic, right? Remember my quadratic equation, ax squared plus bx plus c needs to be set equal to 0. So I'm going to move over these terms one at a time. So this is a positive 2x, so I'm going to undo it by subtracting 2x from both sides. So when I do that, I get negative 4 equals x squared minus 6x plus 4. And then now I'm going to add 4 to both sides, which gives us 0 equals x squared minus 6x plus 8. So now I have x squared minus 6x plus 8 equals 0, which I can solve by factoring, right? I have my c equals 8. And my two factors need to add up to negative 6. Well, I have a positive product and I have a negative sum. So that means, remember, when I'm multiplying to a positive number, that means I can have two positive factors or two negative factors. Since b is negative, both my factors are going to be negative. So I'm going to list out the factors of 8 and then make them both negative. So I have 1 and 8 and 2 and 4. So I'm going to make them all negative. Negative 1 and negative 8 is negative 9, so that won't work. Negative 2 and negative 4 is negative 6. So that is my correct combination. So I have x minus 2 times x minus 4 equals 0. I'm going to set each factor equal to 0 and solve for x. So I have x minus 2 equals 0. And if I add 2 to both sides, that gives me x equals 2. And I'm going to add 4 to both sides. So that gives me x equals 4. So now I'm going to go back to my original equation. So I have the square root of 2x minus 4 minus x plus 2 equals 0. And I'm going to plug in both of my solutions to see which one is correct. So if I plug in x equals 2, I have the square root of 2 times 2 minus 4 minus 2 plus 2 equals 0. So that gives me the square root of 4 minus 4. Minus 2 plus 2 is going to be plus 0. So square root of 4 minus 4 is 0. So I have square root of 0 plus 0 equals 0. So that tells me that 0 plus 0 equals 0, which is 0 equals 0, which is correct. So I have x equals 4 now that I need to check. So that gives me the square root of 2 times 4 minus 4 plus 2 equals 0. So that's the square root of 8 minus 4. Minus 4 plus 2 is going to be minus 2. And so the square root of 8 minus 4 is the square root of 4 minus 2 equals 0. And then 2 minus 2 equals 0 is in fact correct. So in this problem, I actually have two solutions. So x equals 2 and x equals 4 are both solutions to this problem. So now let's try this problem where we are solving for x. So in this one, we have two radicals, right? So what you want to do is you want to isolate both radicals, okay? So we want to make sure that they're separated. And then you're going to raise everything to a power and then solve for x, and you are going to check. So in this problem, you can see that my radicals are already isolated, right? They're already on opposite sides of my equal sign. So I'm going to go ahead and raise both sides to the opposite power, which is to square it. So that gives me 3x minus 2 equals the square root of x squared, which is x. So now I'm going to go ahead and solve for x. So I'm going to combine all my x terms on one side of the equation, and I'm going to do that by subtracting 3x from both sides. So when I do that, I get negative 2 equals negative 2x. And then I divide now both sides by negative 2 to solve for x. So that gives me 1 equals x. I need to check my solutions before verifying them. So I have 3 times 1 minus 2 equals the square root of 1. So we have the square root of 3 minus 2 equals the square root of 1. So that tells me that the square root of 1 equals the square root of 1, which is in fact true. So x equals 1 is the correct solution to this problem. So now let's figure out which graph matches the function f of x equals the square root of x minus 3 minus 4. So once again, it's a good idea to go to Desmos and enter this equation so you can figure out the graph. So you can see that it starts off at the point 3, negative 4. So we're going to be looking for a graph that starts at 3, negative 4, and then includes the points 7, negative 2, and 12, negative 1. So if we look at this, let's see, which graph starts off at 3, negative 4? Well, this starts at negative 3, negative 4, so A won't work. B starts at 3, 4, so that won't work. C does start at 3, negative 4, so it looks good. And then D starts at negative 3, 4, so D won't work either. So now let's make sure on C that 7, negative 2 is included on our graph, which it is. So C is the correct answer. So now in this problem, it says to identify the transformations in the function y equals 2 square root of x plus 1 minus 4. So remember, we're going to look at the transformations one at a time and then figure out what the changes are. So starting off with 2. So the effect of 2, okay, so let's think about 2 is outside the radical. So it is going to be a vertical change. It is being multiplied. So multiplication means that it is a stretch because 2 is bigger than 1. So we're going to say the effect of 2 is going to be a vertical stretch. So now we have this plus 1. Okay, so let's go through and figure out what the effects of plus 1 are. Plus 1 is inside the radical, so it is a horizontal change. It's being added or subtracted, and notice that here it says it's a shift left when we have the addition sign. So we're going to say shift left 1. And then now let's figure out what's going on with this minus 4. So the minus 4, it is outside the radical, so it's going to be a vertical change. It's being added or subtracted, so we go down this way. It's less than 0, so we're going to say it's a shift down 4. So these three changes are the transformations going on in this new equation, right? We have a vertical stretch, shifted left 1, and down 4. So if you graph both equations, the parent function and the transform function in green, you can see that it is in fact shifted left 1 and down 4, and it is also vertically stretched by a factor of 2.